Okay, everybody, let's recap the lesson. So today we talked about literal equations. So if you have literal equations, it really means that you have more than one variable. So just solve them for x, you might have an x and a y or any variety of letters. So variables really are numbers, but we just don't know what the number is. So for an example, the first example talked about, we know how to convert Fahrenheit to Celsius. We have this formula that says C is equal to 5/9 F minus 32. Okay, so, if you're going to be, in the U.S., and you're like, okay, well, what's the temperature in Celsius? You could use this formula. You could just plug in the F Fahrenheit and you can find out what it is in Celsius if you're going to Europe. But you can also then have the formula so it's in terms of F. So C equals F equals. So what we did is we took a look at our equation, C equals 5/9 F minus 32, and we solved for F. We're just going to rewrite it and solve for F. So the first thing we did is we got rid of the fraction, we multiplied by 9, both sides. We multiplied by 9, when we multiplied by 9, the 9 canceled, the 9 there, we're left with the 5 equals 9C then, because I multiplied by 9 is equal to 5 times my F minus 32. Instead of distributing, we thought it would be easier just to divide by 5. So it gets rid of the 5. So then I'm going to have 9/5 C equals F minus 32. Then we add 32, and we got a formula now for Fahrenheit. So if you're in Europe and you want to know what the European temperature is today and figure out what that is in Fahrenheit, because you come to America, you just use this formula. So we have two different formulas now. We have a formula for converting Fahrenheit to Celsius, and now we have a formula converting Celsius to Fahrenheit. So it tells us that currently Josh tells Greg that the temperature where he lives is currently 77 degrees. Greg tells Josh that the temperature where he lives is currently 30 degrees, so Josh must be in Europe somewhere. So we used both formulas. So we took the 77 degrees that Greg has, and we plugged the 77 in. We use our calculator. We got about 10.7 degrees Celsius, which sounds really cold, but we know it's not, because we know it's really 77 degrees. And then we took the other one, and that's Josh. Josh says it's 30 degrees Celsius. Sounds cold, but we plug that into our formula, and we get 86 degrees, which is not cold at all. It's pretty warm. So obviously right now it's warmer in Europe than it is in America, 86, 77, okay? So then we passed the page a little bit longer and went all the way to page 280. Okay, and we had different formulas. So first of all, we talked about the volume of a box. We know the volume of a box is length times width times height, okay? So the volume of the box is length times width times height. But this time, in this equation, we wanted to solve for the height of the box, okay? Rewrite in terms for the height, okay? So I know that's L times W times H. So I did the opposite, divided by L and W, so I can cancel, and all I would have is H. So I divided both sides by L times W, cancel, and over here then I have V, or volume is divided by L times W. Well, that is the base. L and W is the base. So we go down to B, and it says, okay, well, wait a minute. They tell us that the volume has to be 450, and the base is 75. Well, okay, wait a minute. Isn't the base just L and W? It's both L and W. So I took my 75 and I put it in for my base, which is L and W. So 450 divided by 750, the height of the box needs to be 6 inches. All right? Then we looked at another problem about an ice cream cone. And they give us the volume of an ice cream cone here, but I changed it to 1/3 instead of H over 3. So I just modified the thing. So I got volume equals 1/3 pi r squared H. I have to solve for H. Okay, I got to solve for H, so I'm trying to cover up what I did. First thing I did is I got rid of the 1/3. I multiplied by 3, multiplied both sides by 3. So this 3 will cancel that 3. 3's are gone. So now I got a 3V equals a pi r squared H. Again, I'm solving for H. If I put in the invisible times sign, pi times, then I can do the opposite, divide by pi, divide by r squared, cancels, but I also have to do the same thing over here. I divide by pi, r squared, cancel, and we're left with H, because those are gone, is equal to 3V divided by pi r squared. Okay? Now, they're saying, why do we know that it's a linear measurement? Well, volume is three-dimensional. The base is area, which is two-dimensional. So if you take a 3D and divide it by 2D, you're left with a one-dimensional figure. We'll talk about that more another day. Okay, then on number 3, we talk about the form of a trapezoid, and its area equals 1/2 height times base 1 plus base 2, and here it is. Here's a trapezoid. And so this time we want to solve for the height. Okay, we want to solve for the height. So first thing I did, again, is I want to get rid of this fraction, so I multiply both sides by 2. So I get rid of the 1/2. The 2 cancels the 2 here. The 1/2's gone, but I have to also multiply by 2 on this side. Multiply by 2, multiply by 2, I get a 2a. The 1/2's gone. I put in the invisible times sign because this is h times b1 plus b2. Now, if I divide by this entire parentheses, b1 plus b2, cancel, cancel, it's gone, right? So if I divide by parentheses b1, b2 on both sides, then the height is by itself, so my height would be equal to 2 times the area divided by parentheses b1 plus 2b2. Well, the next problem says let's actually use that information. It says, okay, now we know the area is 24. We know one of the base lengths is 9 and the other is 7. So what we have to do is just plug these into my formula. So I'll take my 24 and put it in for A. I'll take my B1, which is 9, and I'll put my 7 here. So I did that. I put my 24 there, and my 9 plus 7 there, and I simplified it. That's 48 divided by 16, which is 3, so the height needs to be 3. And finally on 4, we had to solve in this literal equation for A. So the first thing I did is I subtracted C over D. Just subtract this whole thing, bring it over here because that cancels it out. Then I have Z minus C over D equals A over B. I want to solve for A, okay? So I multiply both sides by B to get rid of the B. So multiply by B on both sides, B's cancel. You get A is equal to B times Z minus C over D. And then I said, well, stop there. We won't look at D. We're going to do D tomorrow because it's really tricky, and I want to do that with the whole class as one problem. Okay, that's all I have. So I will, you guys have some homework to do as a worksheet, and I'll see you tomorrow.